second day of the Data Science Conference Europe 23. This is executive stage, and I'm your host here. My name is Jelena Drašković. I hope you are ready to learn something new today, and you are keen to hear and ask. And I'm happy to see you this morning here. We will start this day with our partners from the Bosch. They are also our platinum partner at the conference and helped us tremendously to make this conference reality. I will introduce you to the Strahinja Miljkovic, who is data engineer at Bosch, and Nikolaos Servos, who is technical lead PT Data Hub at Bosch. Guys, the stage is yours.
Good morning, everyone, and a warm welcome to your presentation, How the Data Flies Above Clouds. You probably already have realized, okay, something gonna have to do with Star Wars today. This gonna be find out during the presentation. So your Jedi today are myself, Nikolaos Servos, in short, Nico. You can also call me Obi-Wan today as a technical lead from the Bosch Power Tools Data Hub. And with me we have
Is it working? Luke Skywalker.
All right. So imagine you're a data analyst or a data scientist, and I've been one in the past as well. What you want to achieve is you want to analyze data. You want to get insights into the data. But as we all also saw in the keynote yesterday morning, data quality of data is really important. I would even go a step before and say, if you don't have data, if you can't access your data, you can't even analyze your data quality and you haven't won anything. And that's exactly the situation where we found ourselves in 2020. So imagine Bosch, quite huge company, over 400,000 employees. Only within our division, Bosch Power Tools, we have 40,000 employers, 22 plants, a very complex IT landscape with a lot of database, SAP systems, etc. And of course, we have also quite, strict firewall rules, so also establishing connections is not always easy. So what did those data analysts did 2020? So imagine, for instance, the social media area where we want to analyze our marketing performance on, you probably know Instagram, Facebook, YouTube, etc. We want to analyze our marketing performance. So analysts loaded those data manually on a weekly, monthly basis, not only one department, but in multiple departments parallel to create the reports. And then we said, okay, those social media channels have REST APIs, so you can somehow automatize these connections. And this was basically the idea of the data hub. So that we said, okay, we're gonna have one central platform where we connect the data, we batch load them on a daily, weekly basis, monthly basis, depending on the use case, and then people just connect to this data hub and can create the reports. Later on, we realized, okay, also other domains, not only social media, but manufacturing, sales, purchasing, want to exactly do the same thing, just simple reporting. And we said, okay, instead of creating multiple parallel architectures for the same purpose, why not combining it all to one platform, the data hub? And then, of course, data scientists came also into the game that pretty much had the same use case, but instead of reporting, performing machine learning, doing predictions in this case. And of course, now we, at this stage, we had a core team of around 20 people. We still have. But the number of data and the amount of data we have in our Bosch environment cannot be integrated only by 20 people. So on the one hand, we said, okay, we have to establish the data hub more as a platform to also allow non-core team members within the Bosch landscape to develop on the data hub, to just avoid so that people build their own independent solutions and have to have the effort to create independent architectures. And of course, also data scientists, sometimes it's just too much to create your own infrastructure just to perform a data science use case. So by giving them a platform, we can directly access the data and create their machine learning use cases. It just speeds up the whole process. So to sum it up, what the data hub is, it became a platform, not a data lake anymore. And so we want to make data easily searchable, accessible, combinable, and usable. And this adds also that we're going to have a data governance and cataloging on top of the data. So I think you heard enough of business slides the past few days, and until now, I want to skip the whole business part and really dive to the technicalities. So what we're going to show you today is really something we now use productive already. So it's pretty much raw what we are showing you. So first, we're going to deep dive a little bit on the architecture, how we really using the data hub and how it's working conceptually, and afterwards, also as a disclaimer, we become quite technically and show really based on a sample data source, a live demonstration with Luke Skywalker gonna steer today. So coming to the architecture. So we developed our platform on Azure. Why Azure? It just gives a very easy scalability. It has a lot of platform service, which just makes the ramp up of ETL pipelines on our service quite easy and simple. So first of all, we have an Azure data lake. For whom you don't know what an Azure data lake is, it's pretty much a OneDrive where different files are just on Azure. Then we, of course, want to save our tabular data. So we're using Parquet to save the data, but with the Delta framework on top of it. So what's the Delta framework? So you know in database you can do ingest, deletes, appends, merges, and basically Delta Lake allows you to do those things on storage level. So if you would do it with Parquet, you have to rewrite your data whenever you want to change, even one row, but Delta Lake makes this so much more efficient and provides you like a format which can be used with the Databricks SQL warehouse, for instance, for reporting, but also data science. It also gives some other benefits like time traveling. So who wanted always to version a database? Delta Lake can offer that now. And also things like schema validation. For our ETL pipelines, we use Databricks, which is a platform for ETL and machine learning. And use Spark in the background, so it's in-memory processing. It's really capable to process very efficiently and fast a huge amount of data. And as already mentioned, it also has like a service SQL warehouse to provision data, and now recently also to store your metadata in a catalog. So the service is called Unity Catalog. Then we have Data Factory. So generally, it's a low-code platform to perform low-code ETL. You can also orchestrate the pipelines and monitor them, and we use them to ingest our data from on-premise due to the reason that, the firewall establishment is way easier with Data Factory within our landscape, and otherwise mainly for orchestration, for orchestrating our Databricks pipelines and monitoring them. Then we have Power BI. You probably heard about Power BI. It's mainly for visualizing your data, but it's also way more capable. So you can also do simple ETL transformations, create measures, perform your modeling in the background, etc. Then we have Azure Purview, which compared to Unity Catalog has like a bigger picture of a full-grown cataloging and governance solution. So you can also integrate not only Databricks data into it, but your whole IT landscape database, SAP, SQL, Oracle, but also other cloud environments. And then for us techies, it's really important we have Azure DevOps. So it's one tool where you can perform everything you need for development. You have your Kanban board, Azure boards, you have your Git repositories, your artifacts, your deployment pipelines. And then we also have Pulumi, which is a provider for infrastructure as a code. Maybe some people know also Terraform. It's similar, just there you can actually code and you don't need those very long, complex JSONs to write anymore. And to sum up the last point, so for me personally, it's really important to know that infra is a code and DevOps is the best thing you can do even quite in the beginning of your project. Because the cloud environments change a lot, and whenever you're going to make a change, you're going to have to do it manually. You might have forgotten which change you have done, and by coding it, you just speed up your following processes. The same thing for DevOps. You want to deploy something to another environment, it's just a mouse click and doesn't need manual work for the data engineers. Bringing this structure into a flow, so we use Databricks and Datafactory for ingestion and processing of the data, store them in the Data Lake framework on Data Lake, serve them, model them in Power BI, orchestrate with Datafactory, govern with Databricks and Purview, use DevOps as explained, and also we are in the beginnings of introducing MLflow. So, of course, we didn't wake up a morning and said, okay, that's the architecture we're gonna go and gonna live forever. So as mentioned, there's a lot of cloud developing happening, and probably this architecture gonna look in a few years again differently. Here I want to show you some of the milestones we had in our architecture development. So 2020, we started with a very simple architecture using Azure Data Factory for ingestion and processing our data, save them in the data lake as flat files, Packet, JSON, depending also on the data source. Use an SQL database and analysis services on top. Orchestration we already did with Data Factory at the time, and what's again really important, you see that we already started very early, I think around 3 months after start of the project at the time, to use Pulumi for infrastructure and create CI/CD pipelines, which just allowed people to really focus on development and not to moving code manually from one environment to the other, like from dev to production. Then we realized, once, okay, Data Factory with the data flows, if you make a pull request, you want to review the code, it looks like a very cryptical line of code. So this was actually a no-go. We said, okay, we need something more sophisticated, which we can review better. Also, the flexibility with Data Factory, if you have people who know how to code Python, was also not the best. And also looking into the future, you want something which really can perform with bigger data sets. So we made the decision to replace Data Factory where possible with Databricks using PySpark. What we did is we loaded all our data into analysis services. It's the same as a Power BI data set. And imagine you're importing gigabytes of data. It's quite expensive. So the promise was the Synapse with caching and materialized flows allow us to use also more direct query connections. It worked partly to say, so that we replace our SQL database with Synapse warehouses. And also started using partly Delta Lake already and started introducing Azure Purview. This was around 2 years ago, or 1.5 years ago. Until then, what we did is we had very simple data source, for instance, from the REST APIs, where we could say, okay, if today I'm getting a data set from today's state, we delete the data and reappend them. So we didn't needed any merge mechanisms. Now imagine you're getting, for instance, manufacturing data, where you have to do quite complex merges, which you can quite simply apply in Delta Lake, actually. It's just a few lines of code, but then you have to write a store procedure, and I hate store procedures on SQL personally. So first of all, why should you duplicate your merge logic twice? So we also have to always consider the data engineers as a cost factor and one other system where something could fail and needs to monitor. So this was one reason we replaced Synapse with an SQL warehouse. Then secondly, you save the data in 2 places. Why should we do that? Let's do it in one place. And the third point was also, within Bosch, we cannot connect to database ports. So by moving over there, SQL warehouse have a HTTPS protocol, and by that it became just very simple for us now to connect to our data. So going again a little bit deeper. So what's the process of integrating a data source? So a data source can be a REST API, it can be also data which are pushed to our system, It can be an SQL database, an Oracle database. So what we do usually is we just move the data, make a copy of them as a batch file, and already starting saving the raw data as delta tables. So quite raw, nearly no transformations. And then we curate the data. So in database, they call it bronze, silver, gold. We call it curated, and what it means is we do very simple transformations, column-based, clean the data, define our data types, tabularize the data if you have JSON, semi-structured data, and this really builds a baseline for further transformations of the use cases. There might be use cases or reports which can directly consume the data. There might be further use cases which need an aggregation. So the history call it aggregation, but it's actually a little bit more. So here we really define our user-specific transformations, views, aggregations, joins of different tables. And for instance, it serves a better performance of a Power BI reports as well, but also the data science project, machine learning projects want one table where all the features are there to directly perform the machine learning on top of it. So, what I want to underline here, this framework, we don't integrate it with all the naming conventions, etc. manually. So we have a Python module where we have standardized this framework with different classes, which you're gonna see later per environment. And we also divided our data in different domains, sales, marketing, manufacturing, etc., which is all coordinated by this Python module. Even the engineers need hours and days to understand it, so I cannot present it within a few minutes now. But you're gonna see a little bit in the live demonstration later on. And that's something I can recommend to everyone to think about if ETL pros can be further standardized. Because what we did 3 years ago, so we introduced it begin 2022, whenever we change something in our structure, like standard columns, folder structure, everyone had to adjust the data source manually. Now it's okay, we updated to Python module 10, please update from version 9 to Python 10, maybe adjust 1-2 lines in your code, and you're done with it. Then I talked about DevOps and the importance of it. So we are using, of course, Git on Azure repos to save our code. So what we have is we have a master branch. There's our code, which is workable. So now I want to integrate a feature, user story, a new data source. We create a branch out of it. The developer tests it, of course, during the development, makes a pull request for review of other data engineers. We complete the development, we deploy it. Then every 2 week cycle, in our case, we make a freeze of this branch and call it then release, whatever release we have, e.g. release M001 in this case, and this is gonna be deployed to QA. We do our QA testing, also together with the stakeholders. If there's some bugs during the testing, we make some cherry picks towards this branch, and then we deploy it to production. Now, also say that we want to enable our data as a platform for other data engineers. So what we did pretty much is we said, okay, if you don't like to go with our release cycles and it's a little bit unflexible, we create for you, for the project team, a different repository, a different data factory, and as we have all parameterized the YAMLs for the DevOps, we just replicate the whole deployment process on different environments. And those are mainly the artifacts, data factory, Databricks, and some configs file which we're managing there. And a nice part of that is in the background, it's still like a central data platform because everything is coordinated and saved within Databricks and or Azure Data Lake storage. But well, in the front end for the developers, it feels like a mesh. So I like to call it something like a soft mesh. And to sum the technical part up, as mentioned, we also do governance, monitoring, cataloging. With all different tool sets, we have the possibility to, classify our data, create a meta model, see the lineage, the schema, and the documentation of the data, see also some sample data and the history of them. Perform data quality, something which is currently private preview and gonna be rolled out soon. We can see the usage insights of our data, who is using the data, how often are they used, with which queries. We can monitor the data, And very important also, we have a security and user access management now enabled with Unity Catalog. As mentioned, we have our data divided into different domains. And for each of the domains, we have different security groups, contributors, readers, owners, where we manage the access for those data. And with that, I want to hand over to you, Luke.
How is this working? Here?
Yes.
Okay, so this is like, we wanted to show you how we do it in practice, basically. So with this live demonstration, we were using the swap API data. So what was the purpose? We wanted to calculate the BMI of all like Star Wars characters and to show them like in some report, Power BI report. As Nico mentioned, this is the orchestration of our pipeline. Basically, we called the API and do all our processes, as you will see in this video. What we extracted was two tables. It's regarding species and people. So basically, in the people, there are data regarding about each character. So for me, I mean, this is not my data, height, mass, and everything, and which species it is correlated. So let's get started with live demonstration. Double click. So first what we do is we create a branch in Azure DevOps, which is connected to Git. By creating this branch, this is the first Azure DevOps. First, this is the structure of Azure DevOps. First, we have boards, repos, where we keep all our data bricks, Azure Data Factory, and etc. And after that, in the Azure DevOps, we create a branch. And by creating a branch, we connect it to our user story because we work with Azure methodology and connect it to repos in Databricks. Connection with the Databricks is made by just taking the HTTPS link and connecting it there. So in the next connection with Databricks is made basically by creating, we went to our branch, create a repo, take HTTPS link, and then after that, we connect it with our branch in Azure DevOps. So after all this fancy stuff that is done, we start with the real stuff. Well, first, what we do is ingestion. In each process, ingestion, processing, aggregation, we first install our module, which is our pride and joy. And after installing our module, we do all our stuff that are not automatized. So in this case, what I did is I create some functions to call the API from the swap and to extract the data. And after calling the API, we decide based on the data that we get, how do we want to save it? Do we want to save it as JSON, or to have some features, JSON Spark features, or we want to save it as Parquet files? And there is a class, ingestion class, where everything is automatized, and we just add all our help functions for this specific use case for data source. At the end, we call our method ingest all properties, which does everything in the background. Also, we choose here, should we use threading to true or false? It is based on the table name list and identifier value list. If you have multiples, everything will be done in parallel. And you can see here our logs, how it works. And after that, we start with the processing. In the processing, what we do, for these use cases, we had to clean some data and also to transform it to calculate BMI per character, basically in the people table. We had some problems because the mass for one character you will see at the end was too big, and the number was like separated by comma. So the program, the Databricks automatically was thinking it was a string. So we had to replace the comma and to say which data type it is. And after that, in the transformation manual method, we calculate BMI and also rename some parts of values for the gender. Here you can see that we have a record date and source update date where we put, because this is the fact table, even if it's small, to track our records per row. And this is by stage how the data frames look like. So in this stage, the mass is replicated. So this big number now, it's not anymore string separated by comma, it's normal number. And in the next data frame, we wanted to show you how it is done, how it's calculated the BMI. Also, what is done in the background, we create, for the ingestion, we create ingestion column. And here you can see also how we create our unique column, which is based on the hash values of some columns that we choose, which we think that are specific. After that, in aggregation, we create the tables that are used for basically creating Power BI reports. In this case, we wanted to join people and species table based on some conditions that we saw. So, and after that, we created 3 more tables. One table we use for Power BI reports. Other 2, we just wanted to show you how we do our aggregation. Also, as every step, it is done in the class aggregation. And the join table is done with the join people species function, which is based on this array contains conditions that we saw when we were working. And we create first a dictionary aggregations where we name the name of the table, aggregated table, and the function that we use. And we call the aggregation process all aggregation. When we, in this case, because it was a small table, we have modes how we save the data. Should we use overwrite or should we use a merge mode? For small tables, of course, we use overwrite because it's easier just to overwrite and append the data without any filtering to based on some conditions. And after that, in these 3 other tables, we did some filtering and some aggregations based on the species and gender. You will later see the data frames, how it looks like. And we have also some optimizations. Basic optimizations are, so we use vacuuming because we are working with data tables in data framework, or z-order. On recently, what we implemented is like a liquid clustering. In this table, you can see here, this is the filter table, the table that we use for Power BI reports. In the next table is that basic aggregation based on the BMI and name of the species, so number of characters per species to know by gender. And also, this is the same, just without the BMI. So after everything we coded here, we also have some in the background configurations that we do. In the processing config, this is only for processing, we have some steps that we do to ease our processing. One of the things is that we have in the YAML file renamed dict. We also have, as I mentioned, primary key list, which we create a unique column based on some columns, and we change the data types of columns with this column data type. And at the end, we do our z-ordering to easier query our data to ease our data analyst job. And after that, after everything is coded, we create a basic pipeline in Data Factory. What we do is we create a sub-pipelines per each table, ingestion and processing, or if it has aggregation. And we wanted to show you here how we do it, how we call our data bricks. We use REST API from the data bricks, and we define our cluster settings, which cluster should we use. Of course, in this case, it was the small cluster. And it is the same in processing. After creating our sub-pipelines, we create the main pipeline. In the main pipeline, we connect all sub-pipelines, and at the end, we do our aggregations. our variables is set for current date, start date, and end date. It's basically we define should we use it for daily or monthly and weekly, as Nico mentioned, or should we use initial for whole period of the data that we have. And after we create our pipeline, next step is basically for our engineers to help us to review what we did. So after saving it everything all, when we basically it is connected to Azure DevOps. By saving it, it is automatically all changes are transferred to our branch. But in the case of the Databricks, as I will show you in the next steps, it is a little bit different. So the PR we create, we define everything, the name of the PR, okay, the descriptions, we connect it to our user story. And after the PR is connected, as you can see here, there is all changes from Data Factory. There is no changes that is made in the Databricks, so we have to go to the Databricks to push our changes to Azure DevOps. After we see if all our changes are there, if the branch is old, we maybe have to pull and then push. And after everything is done, our engineers review. Make some comments, of course, and we merge it to our master branch. We also wanted to show you how we do our cherry picks if we needed to cherry pick it to different environment, like in QA. This is dev, so we want to test it on QA. So we do our cherry picks and run our release pipeline. To transfer all our changes, basically it was from ADF, from Databricks, our meta files, to transfer everything to the different environment, in this case QA. As you can see here, in this release pipeline, when we go there, you can see each step, how it's done. We deploy also our artifacts, etc. As Nico mentioned, this is really helping us a lot to automatize the stuff, so we don't have to do it manually. After all this is done, we wanted to show you how we execute and monitor our pipeline, and also how we create a trigger in Azure, in Data Factory, Azure Data Factory. So we just go to the main pipeline, we add trigger, and we define how we want the pipeline to be triggered based on the daily or weekly. And after we define everything, we wanted to show you by running our pipeline. When we go to the monitor, we can find our pipeline. Also, we can see all our running pipelines, which one, of course, there are sometimes the problems in QA testing, they may be failed or something. And after that, Nico?
All right, now let's see how we can use our data. So here we can see our Unity catalog. So we have different catalogs, dev, QA, production, and we can see also different domains based on each layer. So we have, for instance, manufacturing, aggregated. In this case, we use the test domain in the aggregated zone and choose our data set 2, which basically shows you the name, the BMI, and the species which we join together. Here you can also see the sample data directly, again, the BMI, name, height of the species. You can see also some delta details, like the path, the storage location of the delta table. What I also mentioned, we have, of course, a security concept up top. Here you can really see the security groups which have access to the table. We can also see the history now. So in this case, we did, of course, multiple writes for testing. So we have once create table execution, then 3 writes, and now, for instance, in the last write, you can really see, okay, how many files, paquet files in the background have been written, how many rows in the code have been written, which is sometimes really important. Also very nice, the lineage view. So Strahinja showed you we have 2 tables, species and people, which we join together in the first step. And then based on this join, we create those different aggregations. And Unity Catalog makes it just so simple to see this visualized. We can also see the number of queries we have, who are executing those queries, on which day, what are usually queries which are executed, which just allows us to also optimize our delta tables and landscape in the background. Going on to Purview, we can see similar data, but in future also more, not only the Databricks data, and we're jumping again to the same table I showed before in Unity Catalog. So we can define some table descriptions and some properties. Also see some detailed properties about the tables automatically, again, where it's located. We again can see the schema. Here we even have the option to define rich descriptions about the columns, but also define glossary terms and other classifications column level-wise. Soon we're gonna see also the lineage. This feature is not available by Microsoft yet, and then we can add some context or also see like the dependencies of the different tables within our landscape. And I think I'm playing here around a little bit longer than I should in the video, but basically that's also a new feature which I discovered on Purview recently, so you can also classify now by adding text to your tables. All right, Power BI. Now all the data analysts were waiting for that. So what do we have to do? We have first of all to check for our connection details in our SQL warehouse in Databricks. We established a connection, and ta-da, you can see the same data we saw before in our Unity catalog. So in this case, we go again to the test domain, load all the tables, publish them to our Power BI service workspace. Now we do a very simple transformation. As mentioned, I'm not a data analyst, so I did it very simple. So a simple table, we sort it based on the BMI, or we can even create a visualization for the BMI, height, mass, species, and the person itself. So, and now to answer who is the winner. So the biggest BMI has Jabba. So we couldn't put the picture here, unfortunately, but feel free to Google it if you don't know who it is. It's basically a very big frog. You can also see some statistics about Jordan, for instance, 39 BMI, also quite interesting for me. And to sum up our live demonstration, so we really made it. The force was with us, to say. What we achieved, like the main thing is, we showed you with our data module, we integrated the REST API. A simple one, but you also saw that the engineer needed only to focus on the main code to perform the transformations of the data. Also all standards like naming, conventions, the folder structure, standard columns, metadata has been generated automatically. So we could also easily orchestrate the data and deploy our code to production. Well, in QA in this case, but let's assume it's production for the scenario now. And so we were also able to monitor the data, and as said, to simply visualize our metadata, like the usage insights, the schema, the lineage. And of course, all the engineers know it's not always the perfect world when you are developing. Of course, when we started developing the API, some code lines might not work straight away from the beginning, but that's why we do testing before we deploy things. I hope everyone is doing testing nowadays. And also, like I learned from my side, like data types is really important in cleaning of the data. And of course, this is not always possible to perform only by the data engineers. There we need to support from stakeholders who know the data or data stewards, but also the data analysts who are going to consume the data. And at the end, the use case, the data analysts, the data scientists for the reports and machine learning models define also how the data should be at the end, latest in the aggregated zone being provisioned to them. And with that, I thank you very much. And now I think we have some time for questions, right?
Do you have some questions?
Thank you. Very interesting. I wonder where in this journey is your business user, and like which parts of it do they get to do, or it is just your team that provides them like the BMI, or they are participating also in the previous steps of the analysis?
Yeah, so usually the case is together with engineers, we can have a stakeholder meeting together to define the requirements. Okay, how do you need the data? So that people already know as soon as possible how to transform the data. I think it's really important because we also had some case out of the history where, okay, the stakeholder didn't have time or they just gave the data and then we should find out everything by ourselves, and then it was like a rolling loop. We had to make assumptions and then data has been violated later. So that's how we are really doing it right now, to have like the results or good results straight away in the beginning or as soon as possible, if this answers the question.
Let me ask another way. You mentioned self-service BI or self-service analytics in one of your slides.
Yes.
What does it actually mean? That someone can access raw data and do their stuff in Power BI, or they have to always go through this process of actually aggregating it before they can access? What is the strategy?
Okay. I now understood. So the aggregation is always an optional step which can help them. So usually it's quite simple. You know which domain you want the data to. You can find in our Unity catalog. You apply for the security group, and then you can just connect to the data. So you can connect to the raw curated data, but also aggregated data. So we want to keep it quite simple because we don't want to overcomplicate. I think we do it already too much at Bosch.
Thank you.
I have a bit of a related question. To whom do you open your catalog? It's only analysts, or it's also
Everyone.
everyone?
Everyone. Also data engineers benefit, because not every data engineer knows the data source, for instance, very in detail. Also stakeholders want to
business people who might not really have a role in data.
A stakeholder might ask, do we have sales data there? So, okay, maybe he will not be understanding it that good as a very deep data specialist, but at least he gets some kind of an overview.
Okay,
Yeah.
okay, thanks.
All right.
Doesn't know the full potential of the data sets. How do you control the costs when accessing, especially when you are working with signups, when you have dedicated pools? How do you control the costs from all parts of the world where people are working in different zones, different times, and so on?
So we have, of course, a cost management and alerting rules, and that's where we observe. I have to say, as we were on the beginning, and it's also a strategic investment, we didn't make the rule of the cost very strict. Also in comparison to our on-premise database and ETL pipelines, usually people were surprised, what, you're running all those 40, 50 data sources only with 100,000 euros per year. I'm paying for one data source or one area of data already more. So this was already an argument enough. But of course, we monitor the cost very often and have done multiple cost improvements measures within the past year. So I think now this year we went down with our cost 30-40% already.
Okay, thank you guys for your amazing demonstration. It was very interesting. I have a certificate of appreciation for your engagement in the conference. Thank you. It was great to see you here, and I hope to see you again. Thank you, Niko.
Hvala.
Hvala.